I can state the claim. So number one, state the claim. The null hypothesis, mean of the population is $80. The alternative hypothesis, the mean, well, they talked about at least. So because the keyword is at least, it's a one-tail right test. It's a one-tail right test. Number two, the next thing is I'm going to state alpha. So alpha is given to me as 5%. And because it's a one-tail test, I'm not going to divide alpha by 2. It's a one-tail test, so I will not divide alpha by 2. So this is a t-test, one-tailed right. One-tailed right. A t-test, one-tailed right test. All right. So then I will find the critical value for t. I'm going to find the critical value. The critical value is t, okay, inverse t. Area to the left is 0.05. The sample size is large, but I don't know the, so because the sample size is large, I can actually use, so 46 minus 1 is 45, but still I don't know the population standard deviation. So that's why so it is 45. And by the way, I want to make sure that okay, 46. So degree of freedom is 46. I want to make sure that I put in the right number. 46. Okay, and then I'm going to calculate. And the critical value is negative 1.668. But I'm doing a right tail test, so I'll change it to positive 1.68. So I will draw a normal curve. Positive 1.68 is the boundary line between the rejection region and acceptance region, 1.68. The boundary line between the acceptance region and the rejection region is 1.68. Okay, so now I will find, I already found the t. It is 1.68 because it's a right tail test. So I change the sign. Normal curve is symmetrical. Now I want to solve the value for t, test statistics. Step 4. So the test statistics t is equal to x bar minus mean divided by the standard deviation over square root of sample size. Okay, then I will put them in. I will just put everything in. All right, so t is equal to x bar. And that x bar given to me is, let me look at it again, the sample mean. What is the sample mean of that? It's 84. Let's see. Let's see where the sample mean is. With the standard deviation of that, a sample of 46 is taken. Oh, okay. The sample mean is 84. So it is 84 sample mean minus status quo divided by sample standard deviation, which is 4, divided by square root of sample size. And sample size is 46. So I will just, 84 minus 8 is 4. So 4 divided by, I can just do reciprocal. So it's going to be square root of 46 over 4. Square root of 46 over 4. and 4 will go. So now I need square root of 46. Therefore, the value of t is square root of 46. So square root of 46 is the value of c. And when I hit enter, the value of t is 6.78. So t is equal to 6.78. That is a large number, a large t. Falls into the rejection region already. The value of t falls into the rejection region on the right. Rejection region on the right, because 6.7 is right here. So that tells me I will reject the null hypothesis. I will reject the null hypothesis because the characteristics of t rejects the null hypothesis, falls into the rejection region. And because it's a right tail test, I rejected the null hypothesis. Then I have rejected the claim. In other words, the alternative happens. Actually, the average cost of a calculus textbook is more than $80. So it is no longer $80. It is more than $80. That's what I will go and tell in my decision making. I will go and tell those who hired me, the status quo has changed. Therefore, the average cost is now greater than $80. So average cost is greater than $80. Is greater than $80. Okay. And I can actually put everything in my calculator. So let me go to my calculator and make sure that everything I calculated is right. So I'll go to start, arrow to test. And what kind of test did I do? I did a t-test. And the status quo is 80. In other words, the mean we are debating is 80. The mean of the sample is 84. The sample size given to me, the sample size is, let's see. Okay, sample standard deviation is 4. The sample size is 46. Therefore, the kind of test I'm doing is a right tail test. My calculator knows the kind of test I'm going to do. It's either a right tail test or a left tail test or a two tail test. So I like to draw. You don't have to draw, but I like to draw. When I draw, I can get everything, including the value of t that I calculated. So the value of t I calculated is the same, 6.78, falls into the rejection region. The probability of accepting the null is 0. In other words, alpha is 0. 0 is less than 5%. The probability of accepting the null hypothesis is 0. And that is less than 5%. Reject the null. So p-value and the t-value both rejected the null. So I reject the null because p-value and t-value fell into the rejection region. P-value is less than alpha. So we reject the null. If p-value is greater than alpha, we will accept the null. If t falls into the acceptance region, we shall accept the null. But t did not fall into the acceptance region. That's why we rejected the null hypothesis. And therefore, the average calculus textbook costs more than $80. The average calculus textbook costs more than $80. Okay, so this is a real world problem, and that's the first example, example 1. Let's go to example 2. Let's find the example that will actually, let's get an example that will be a two-tailed test. So we have just done a right tail test, an example with a right tail test. So let's get a two tail test. Let's read question number 22. A manufacturer of light bulbs claimed that a light bulb have a mean lifetime of this hours with a standard deviation of that. A random testing of 144 bulbs yielded that. Is there a reason to doubt the manufacturer's claim? So let's read what the manufacturer says. A manufacturer's light bulb claims that its light bulbs have a mean life of at most. So this is a left tail test. At most, the keyword is at most. And so because it is at most, let's just look for a test that is a two-tailed test. Okay, so let's look at question number 23. Question number 23 says, a child psychologist claims that the average number of mistakes an 8-year-old will make on a skills assessment test is. Okay, so we see is here. Is means exactly. So is and exactly are the same. They also mean a equal sign. So question number 23 is a two-tailed test with a standard deviation of 2. So the status quo now is mean is equal to 6. All right, so that's what we are testing. Because of this, we're going to state the claim. Null hypothesis, mean is equal to 6. And therefore, alternative hypothesis, mean is not equal to 6. So because it's a two-tailed test, the alternative hypothesis will be not equal to. So what am I given? I am given the standard deviation. Sample standard deviation is 2, and a random sample of 48. Okay, so sample size is 49, and the mean of this sample is 7. So X bar is 7, and let's see what else. Use p-value. So the first question says use p-value. So we have to use p-value to do the test. And also, does 98% confidence interval? That's a good question. So we are going to do two kinds of tests. We will use p-value to test the claim. We will also use confidence interval to test the claim. All right. So first of all, let's state alpha. So alpha is 2%. Alpha is equal to 2%, or 0.02. Therefore, critical value for alpha over 2, we're going to divide alpha by 2. Why are we dividing alpha by 2? Because it's a two-tailed test. So alpha divided by 2 is equal to 0.01. Okay, so we draw a normal curve to look like this. All right. So two-tailed test. This is 0.01 on each side. The area is 0.01 on each side. And then I am going to calculate the critical value. So inverse T 0.01. So I'm going to use my calculator. Turn this on, find inverse T. The reason why I have to find that is so that I know what is the boundary line. So 0.01 is the area. And the sample size is given to me as 49. Even though sample size is greater than 30, we don't know the population standard deviation. So we still have to use T distribution. So I'm going to calculate By the way, I have to use degree of freedom of 49 minus 1. So it's going to be 48. It is 48 because I have to use degree of freedom of n minus 1. So I'm going to delete that and then close parenthesis. All right. So, and then I hit enter. Okay. So the critical value on the left and then the right are plus or minus 2 over minus 2.4 on the left, 2.4 on the right. Okay. Okay. So now that I have 2.4 on the left and the right, I found the critical value. Now I will complete the test. The test did not tell me to use the test statistic. Rather, it told me to use p-value. So I'll go ahead and post this in my calculator. So I go to Start, arrow to Test, and do t-test, which is number 2. And I'm given data. I'm given statistics. So what is the mean that we are contesting is 6. The sample mean is 7. The sample standard deviation is 2. The sample size is 49. I'm doing a two-tailed test, and I want to draw. So the critical value is 3.5. Alpha is 0.001. So since alpha is 0.001, alpha is less than, p-value is less than alpha. So p-value is less than alpha. Is less than alpha. So alpha is 0.01, actually 0.02. But p-value is less than alpha. So we reject the null again. So we're going to reject the null. And actually, if I use the value of test statistic, I have that test statistic is 3.5. So even the test statistics rejected the null. Test statistics falls into the rejection region. So I reject the null because p-value is less than alpha. And since p-value is less than alpha, I have rejected the null, which means the conclusion is that the status quo has changed. It is no longer 6. It can be greater than 6 or less than 6. Because I hope you know that that's what not equal to means. Not equal to means that it can be greater than 6 or less than 6. Can be greater than 6 or less than 6. Okay. And then I am also told to use the confidence interval to make the same conclusion. So I'm about to use confidence interval to make the conclusion. So let's do T confidence interval with 98% of confidence. All right, so using the T confidence interval, I'm going to draw a number line. I already know the test statistic. Okay, so I actually know what the sample mean is. The sample mean is 7x bar, point estimate. So the point estimate is 7. And what is the lower bound? I don't know, so I have to calculate that. We don't know the lower bound yet. We don't know the upper bound yet. But when we find the upper bound and lower bound, we want to know if the status quo is contained. Is the status quo contained in the interval? Can I find 6 from here to there? So that's what I'm going to test now. That's what it means to use confidence interval to do the test. So I'm going to clear. I'll go to start, arrow to test, and I am going to use T interval, T confidence interval. And so I know that X bar is 7, standard deviation is 2. The confidence level is 98 because alpha is 2. Anytime I'm given alpha, I already know the confidence level. So calculate. So I found that the lower bound is 6.3, the upper bound is 7.7. Lower bound is 6.3, upper bound is 7.7. So the boundary line, this interval does not contain the status quo, does not contain 6. 6 is on the left-hand side of the lower bound. In other words, 6 falls into the left-hand rejection region. Therefore, we reject the null hypothesis. So that we rejected the null hypothesis, we are now saying that the average mistakes that the 49-year-olds make must be greater or less. Actually, it says it's less. It's less than 7. So it is less than 7. It's not exactly 6. Okay, so this is example 2. Let me see if you have any question. We just did 2 examples of hypothesis test requirements. So do we know the formula? Yes, we're actually given the formula here. And this formula can be rewritten as sample size is equal to critical value for Z, alpha divided by 2, population standard deviation is given, over margin of error, E means margin of error, all squared. This formula should be given to you in the formula sheet. Let me see if you have a question. So this is calculation of sample size for mu. Let me see if you have a question. So I'm going to calculate the sample size, calculation of sample size. So I am going to calculate the sample size right here. What am I given? So let's see what we are given. Sample size is equal to, I am given the confidence interval, therefore alpha is 5%. So I will find inverse norm, because this is Z, inverse norm. Divide 5% by 2, or is it 0.025? And the mean is 0, standard deviation is 1. So I am going to calculate. So inverse norm, second inverse norm, number 3. I am looking for critical value, and when I get that, I multiply by standard deviation, and I divide by margin of error. So actually, let me write all this here. This is critical value. What is standard deviation? The standard deviation is it given to us with a standard deviation of 6 and within 2 millimeters. So margin of error is 2 millimeters. And I have to square all of them. Within means plus or minus. So let me put all of them in together. So the area to the left is 0.025. The mean is 0, standard deviation is 1. I am going to paste and get an answer. Then multiply that answer by standard deviation, which is 6. I get an answer. Divide by 2. I get an answer. Then square then square that answer. So this is the sample size. Whenever we calculate the sample size, we must round up. We must round up, even if the answer is 34.1, we have to round up to 35. Because you don't really know what this. If it's a table, there is not anything like 0.1 table. There is nothing like 0.1 table. So we are going to round up. Sample size is equal to 35. Rounding up. You must round up in every sample size calculation. Therefore, I am 95% confident that the sample size that the manufacturer will use is 35. The manufacturer should use a sample size of 35. So this is calculation of sample size for mean. The formula is always this. I rewrote the formula here. Is critical value multiplied by standard deviation over margin of error. So you calculate the sample size. So the next thing I want to do is calculate the sample size for proportion. Let's calculate the sample size for proportion. Calculation of sample size for proportion. So let's get a sample size, find sample size for proportion. Okay, let's see. What is the negative confidence interval? So I'm looking for sample size for proportion this time. So we have done 3 examples, 2 on hypothesis testing, 1 area to the right tail, 1 two-tailed, and then we have done calculation. All right, so we found calculation of sample size for mean, but the next thing is find calculation of sample size for proportion. That's what I need.